Hi there. This is the presentation of real-world command F syntax detection. And this is my final project for designing computer vision app. So in case you don't know what is command F, here's a video shows that how do you use that. I think everyone have used this. When you want to find something in a browser or in your computer, you just type Command F or Control F, and then type what you want for, and then it will show you where is the target you're looking for. So today outline, I'll first talk about you know what is the Command F in computer. So what is real world Command F? And that will be in the project scenario, and there will be more like motivation in it. And then it's project objective. Specifically talk about where is the problem for this thing, and then it's my methodology, how am I going to deal with this problem. And then it's the environmental setting. It's if you want to build an apps like this, what kind of libraries or software you need. At the end, I'll show some results I have taken and then the future work. So project scenario. What is the real world command F? So imagine you take this function out to the real world. You just take a picture and you can find where is the word you're looking for. And so there's a lot of application for this, such as like helping the visually impaired people um, in their daily life. Like there's maybe a bus coming, or maybe there's a stop sign. You can tell the impaired people, visually impaired people, like you shouldn't cross the street, or there's you want to go to the gym or something. And then it's a language translation. Um, it's really useful now when you're like traveling around the world in different country. Um, it's a world. Yeah. So you don't know Portuguese. You went to Brazil, and there's some sign on it, and the people don't know English. So how can you read those things? Or also like the menu on it. And third is more academia. It's the robot navigation. Um, Actually, syntax give a lot of like clue for a robot to navigate, but we haven't used that a lot. And at the end, of course, or you just get lost in your menu, or get lost in the a lot of like billboard, street signs. So before I go through all this, I'll first talk about what is a commercial OCR. Commercial OCR is actually quite well known in the document images. Um, I think everyone have using the scanner. Yeah, actually they're using that technique, but it's really poorly on general images. Um, that is the syntax, uh, the natural sync. Why is really poor? Because the technique is really low level, such as binarization. Um, so it just simply thresholding operation, and they assign each pixel. If it is higher than intensity value, it will assign to there's a background is white, and if it's lower, it was black. And of course, there's some adaptive thresholding, but it's still not enough for natural sync. So what is the problem here? First, um, in ICDAR 2015, there's a competition called Competition on Robot Reading. In 2015, they have um, identified those problems. In 2015, they they set the challenges incidental syntax, which is actually I did explain before. Look at these pictures. Can you recognize where's the text in it and what is it saying? Yeah, we can, but machine cannot. So how can we deal with this? So there will be two tasks. Um, First is text localization, and that is you have to first know where is the text in the scene, and then it's word recognition. And after you get the text in the scene, you can apply techniques such as the traditional OCR or um, convolution neural network. You can learn the model. So here, I'll first talk about the text localization. Um, how I'm going to use is I'm going to use a technical extremal region. Extremal region is you can regard images as a 3D um, structures. So you can see from this picture there's some black hole and some white background, and connect with them there's some blur in it. So how we realize it, you can see as a 3D structure with X, Y location, and the Z is different layer of the intensity. If you want to find the contour, actually you can follow along those peaks. If the peak is steady, changing with different layer, actually you can say those are in a one character or one structure. So by this way, there's two properties. First is the continuous transformation of image coordinate, and then it's monotonic transformation of image intensity, which is I explained before. So referenced by this paper, real-time lexicon free syntax localization and recognition 2015. Actually, they have a paper in 2012 and a similar method. And they're using those method. And so um, by the extremal region, you can actually regard a region as a tree. When changing from different layers, the word is becoming obvious, and then you can extract words from those regions like O and Y, and then you keep extracting and growing the tree. So this tree can give us a lot of stuff, such as the descriptors, and those descriptors such as area, perimeter, bounding box, and Euler number. All these properties you can find in the paper. And also another characteristics for this method is the computational times in O1 for each reason, which is why we choose this relative fast if we want to do a real time. And then is a class condition property. You will come out with this method and then put this property into the second stage. In the second stage, um, actually you want to be more accurate, they put in a more computational expensive features such as hole area ratio. Like the O have one hole, the hole area ratio can compute by that, and convex hole ratio, and then some number about outer boundary inflection point. Okay, so now we have um, extremal region for text localization, which is give us where's the text and give us some feeling or some a descriptor of the those region. And then we use the segmentation. We can regard this as a segmentation, and we use those segmentation to come out um, with the properties we can put into our word recognition. That is we're in here. I'm going to try the traditional OCR. Hope that works. So some environment setting. First, I'm going to introduce three libraries or you can say software. Is first Laptonica. Um, I think everyone knows the OpenCV. Laptonica is another like image processing and image analyzing applications. I'll talk more detail in the next slide. And then there's the of course the OCR engine, and there's one well-known engine is Tesseract. Last is the open source computer vision, the well-known one, OpenCV. But here I'm going to talk about OpenCV 3.0 and its extra module. So Laptonica library, it's well-known application with document images. So the OCR, actually the OCR engine is combined with this library. And then some natural images, which is good news for us. And third, I repeated its image processing operations such as scaling, translation, rotation, shear, binary. A lot of operation you can do in OpenCV. You can also do in Laptonica. And the second one is Tesseract. Tesseract is probably the most accurate open source OCR engine available, and it combined with Laptonica, yeah, I mentioned before, and its wide variety of image format. And third, it's over 60 languages, and now it's being improved extensively by Google. So you can find there's the open source in this GitHub link. And that's the most important thing is the OpenCV extra module. OpenCV developed extra module separately and published in the OpenCV contributor repository. And new modules quite often do not have stable API. Also, they are not well tested. So this extra module is not included in the official OpenCV. That is, if you want to build an OpenCV framework to use on your Xcode project um, in iOS app, you cannot use the one you download from the website. You have to build your own one. So there will be some reference on the net, but I hope I can try to put some tutorial in my GitHub. Oh yeah, and this reference, it's good for you to try to build your own framework. Okay, so we have our localization method. We build an app called Command F, and then we have traditional OCR. And let's see what's the result and what's the difference. Okay, so the right side is the traditional OCR, and the left side is the only local using external origin to localize. So the result is kind of similar, and sometimes because the simple background, the traditional OCR have better result. You can see the third floor is for quite study, and also our localization find out those words in the region. But the traditional one can recognize more like group study area available. There's some like typo like in they recognize as yeah, but generally it's good. How about in syntax localization and recognition? So here's two examples. First, we use the traditional OCR and we take a picture and a process. And for the AD1, yeah, the white one, that means it cannot recognize anything. And the Carnegie Mellon one, they recognize a really weird word even don't know what is it. And for the new OCR, the text recognition using Tremor region, it's you can see um, actually bounding box are bright, kind of good region. And there's some more result I just screenshot from my cell phone. Yeah, some word is good, but eventually they get something. So generally, this method is kind of work. So feature word, I want to combine text localization, extreme origin with the word recognition on traditional OCR, and now it's about um, 1 second to for the um, text localization, and it's about um, I think maybe like 10 seconds for word recognition OCR. So test the real time implementation will be a challenge, um, but it will be in my future work. So you can find the my project in this GitHub uh, link. So yeah, thank you for listening, and I hope to see you soon.